All right, lesson 7 is the last lesson in this unit. It's on adding and subtracting rational expressions. This is different, okay? So we are going to be following some different rules when we add and subtract. A rational expression, we just have polynomials written as fractions, and we're going to add and subtract fractions. Remember, when you add and subtract fractions, though, you need a common denominator. So that is really important. There's going to be some things that we learned previously that don't work anymore. Like when this is a subtraction question, I can't go and cancel out this 3 and this 6 and reduce because I have fractions that are separate. There's not multiplication in the middle. So these fractions, we have to have a different plan of attack. It's not the same thing as multiplication. So we need a common denominator in order to add or subtract the numerators. So you might remember something like 2 over 5 plus 1 over 5. What we do when we have fractions, we have common denominators. I keep the denominator the same, right? That does not become 10. I keep the denominator the same and I just add the numerators. That's what we're going to do, but we need a common denominator first. So this first one, I really focus on the denominator. I need a common denominator between 6 and 4. You could just multiply those together to get 24, but normally we try and go with the lowest common denominator, which I think here would be 12. I have to multiply 6 by 2 to get 12, so I have to multiply the numerator by 2 as well. So I get 12 in the denominator and 10m in the numerator. And then 4, to get 12, I'd have to multiply by 3. So I have to make sure I do the same thing to the numerator. So I have 9m over 12. And 10m minus 9m, I don't know, some people might suggest that you think of this as one fraction with a common denominator of 12, and then 10m minus 9m in the numerator. That's not a necessary step. I can just subtract my two numerators to get 1m over 12. We're not dividing anything out. We're not canceling anything out. I don't have any restrictions here. I don't have any variables in my denominator. Okay, part B, I notice that I already have a common denominator, and it might look a little different than what you're used to, but I have a common denominator. So that means that I can just add or subtract my numerator. 7y minus 5y is 2y, and I keep the same denominator, 2x plus 1. And that one's done. Here again, I have common denominators already, so I'm safe to go ahead and add my numerators together. They are not like terms, so I would just write k plus m over k plus m as I keep the same denominator. That's really equal to 1, but I might state a restriction there where k can't equal negative m. Over here, I don't have common denominators. So even though there's a variable, I can still think of a common denominator here being 6. I'd have to multiply this side by 3, so I have to multiply the top by 3, and this by 2, so I'd have to multiply the top by 2. So I'd have 21 over 6m plus 10 over 6m. And 21 plus 10 is 31 over 6m. And I'm fine with that. I know it's an improper fraction, but there's a variable in the denominator. I'm okay with improper fractions for sure. Here again, I need a common denominator. I'm looking for the lowest common denominator, which could be 12x. So I'd have to multiply here by 4. I'd have to multiply here by 3. And this term I'd have to multiply by 6 to get common denominators. So I have 12x, I'd have 8 minus 9 over 12x minus 6 over 12x. And I can just, since I have common denominators now, 8 minus 9 is -1, minus 6 more is -7 over 12x. Okay, hopefully this makes sense. It's completely different than when we multiply and divide and we're trying to cancel out terms. We're trying to simplify mostly by just collecting like terms in our numerator and keeping the same common denominator. So it's just a different way of different type of question. Here, it looks like I could just multiply this side by 2 because that would give me 4a for both denominators. But here I'd have to multiply by 2, but be careful. That means I'd have to multiply the entire numerator by 2. And that would now be over 4a. And here I would just have a plus 1 over 4a. Now that I have the same denominator, I would add my numerator together. So it looks a little weird. Let me just write it like this first. Then I'd add the a plus 1 all over 4a. But it's a good idea to keep your denominator in simplest form or factored form. And in the numerator, I would like to maybe do some distributive property because I need to simplify the numerator as much as I can and collect like terms. So 2a minus 6 plus a plus 1 is going to allow me to simplify that even further. So it looks like I have 3a minus 5 over 4a. And I haven't canceled out anything in the denominator, so I don't need to state any restrictions for that one. Here, it looks like I know I have two different variables, so maybe a common denominator would have to have an m and an n in it. So I'm thinking my denominators should be 6mn. So how did I get that then? I would have had to multiply that side down here by 2n. So I'd have to multiply the numerator by 2n to give me 4n. This side, to get 6mn, I would have had to multiply by 3m. So I'd have to multiply the numerator by 3m. So that one's a little trickier. So in my numerator, those are not like terms. So all I can do is just write 4n minus 3m. And my denominator, I keep the same denominator, 6mn. This one, oh, so close, right? But this one is an n, this one is an m. I would have had to multiply to get denominators of 3mn. I would have had to multiply this side by an m, so that would give me 5m squared. And the right side, I'd have to multiply that by an n, so that would give me 4n squared. So the idea is just to get common denominators. I simplify the numerator and collect like terms if I can. If I can't, I am writing this as the numerator, and now I have one single denominator. And it may not feel like you accomplished much, but there, we've added those fractions together. We got a common denominator and we simplified the numerator. So this one, they're going to get a little trickier, but not too bad. I hope you don't mind. Here, I already have common denominators, which is great. So my numerator, there's all these little tricky things I'm trying to show you. So 2s plus 7. You have to be really careful here. That minus sign, it has to be distributed to both of these terms. So maybe you'd like to see it written like minus 6s minus 4. I don't know if you would. That minus sign doesn't mean just subtract the 6s. You have to subtract also the -4. And we have one denominator of s minus 5. So to simplify my numerator, -6s plus 4 over s minus 5. 2s minus 6s is -4s, whoops, 4. And 7 plus 4, 79, that's 11 over s minus 5. This one here, I don't have a common denominator. Okay, this one is going to get trickier. I need a common denominator. And sometimes if you can't really figure out what the common denominator is, you would just multiply the two denominators together. So my common denominator, let's see if this makes sense, is c times c minus 1. C times c minus 1. So if I'm really stuck and I'm not sure what to do, I multiply them together to get a common denominator. That means this side I had to multiply by c, so I'd get 2c squared. And this side I had to multiply by c minus 1, so I'd get 5 times c minus 1. So I did all that. It's kind of imagining what would I have to do to this side to get this denominator, and I have to do the same thing to the numerator. Now that we have the same denominator, we can just look at the numerator, 2c squared minus 5 times c minus 1 over, I just have one denominator. So this is me accomplishing the task of subtracting these fractions. If I can simplify the numerator, I would do that. This is going to be kind of a weird rule, plus 5. And then I don't want to simplify my denominator, which is kind of weird. You'll be like, why is that? Normally when we have factored form in the denominator, it helps us with restrictions. We usually leave our denominator in factored form. The reason we're not doing that in the numerator is because we're trying to collect like terms and simplify the numerator for the process of subtraction right now. But it's really, really a good idea just to leave your denominator in factored form. So over here, this is where we get a little tricky here. A lot of these are subtraction. They could have been addition. Doesn't matter, but same kind of strategy. This is kind of a mess, but in order to get a common denominator, this left fraction would be x minus 3 times x plus 1, because I can't do anything except multiply them together. And this common denominator would then be x minus 3 times x plus 1. So in the numerator, you think, okay, what did I have to do to this denominator to get this down below? I had to multiply by x plus 1. And over here, what did I have to do to this denominator to get this? I had to multiply by x minus 3. So now I have a common denominator and I'm able to collect my like terms. Maybe I would just write it like this first, just for continuity here. And I'd have one denominator because this is the process of subtracting. So I keep the same denominator and I add the numerator. So to add the numerator, I should probably expand using the distributive property, because then I'll be able to collect like terms. I don't want you to, and you might be happy about that, it's less work. I don't want you to expand the denominator or change the denominator. I would like you just to leave your terms in factored form in the denominator. But you see in the numerator, we're actually able to subtract our terms and collect like terms. I'm just trying to put 4x minus 2x is 2x, and then 4 plus 6 is 10, and I would keep the denominator as it was. And this would be true as long as x doesn't equal 3 or x doesn't equal -1. I'm not requiring you to write any of these restrictions because I'm not canceling anything out. And I can see that those are the restrictions right here in your answer. Okay, last one. I see I have a little bit of factoring to do. So if I factor in the denominator, I think 3 times 5 is 15. And if the 5 is negative and the 3 is positive, I would get negative 2. And then I just have 3x minus 5 over here. Or sorry, 3x over x minus 5. Okay, why did we do that? So as always, we factor first. If you see any factoring that needs to be done, you always factor first, whether you're multiplying, dividing, adding, or subtracting. So I always want to factor first because it helps me see what kind of common denominator I need. My denominators have something in common here, this x minus 5, but they both don't have an x plus 3. So I could leave this one as it is, x plus 3 and x minus 5. But this denominator over here, I also want it to be x plus 3 and x minus 5. Well, it already had an x minus 5, but it didn't have an x plus 3. So whatever I do to the denominator, I have to do the same thing to the numerator. Now that I have the same denominator, I would just have one fraction, but I want to kind of simplify. This would be minus 3x times x plus 3. And I'm going to keep my denominator. Don't mess with the denominator after it's in factored form. Just leave it as it is. That's what most teachers would tell you. In the numerator, I still have some simplifying to do. This would be negative 3x squared minus 9x over x plus 3 times x minus 5. And then if I write those terms in descending order of x, I guess I'd have negative 3x squared. I'd probably put that first. 1x minus 9x is negative 8x. And then minus 7, I don't have any other like terms. And this is my simplified subtracted, and it could have been addition. It would have been the same. That is my simplified answer, and that's as much as I can do.